Okay, this is a video for Lab 6, and this probably will be the last video for the CAD part. And today we're gonna assemble the cutter or the pliers together, and we're also going to talk about the drafting, which will give us the mechanical drawing of this part. Okay, so some basic concept. Um, there are two types of assembly design. So you have top down and bottom up. What we did is bottom up. First, we design the individual parts for this whole project. Then we put them together. That's from bottom to the top level. So top down is basically your first think how your machine will be on, what the functions of your machine will be. Then based on the function of your requirements, you design the overall shape of the overall uh, assembly first. Then you divide those functions into individual parts. So that's a totally different design method. Anyway, just get to know them. Um, then we will start the assembly. So what you will have is something like this, and as you can see here, we have some overlapping on the handle because these two are exactly the same. So it's not um, realistic, but it's idealized model. So we just put it this way. And the spring we just put there. So um, the angle of this spring, we don't have to change it. We will fix this, the legs of that spring, as well as this latch. We will not move this around. Just put it there. You know. All right. So let me close this. And first, you're gonna build a new file, which should be an assembly file, and find the place where uh, your model will be. Okay, so you want to put all the files on the same folder. Otherwise, it's gonna be weird. Sometimes NX will have some errors. So just put the assembly file under the same folder. So here, okay, and you can get a nice name for this part. All right, so when you first start the new file, it will ask you you can add the file or add the components here. And let's open some parts. So let's say we want to add the bottom blade first. So basically, you have one here, and you can multi-select. And if you have the parts open, they will be here already, and you can pick from this window. And you can also multi-select and insert them all at once. And that's your positioning, and you have some different options. So for me, I would just insert to the origin and move them later. And here, the reference set, usually we don't do anything to it, just keep this default. So after you click OK, you will see the 3 parts, and they are all inserted based on the absolute origin. Okay, and if you don't like the sheets, well, we have to hide them later. We can do it now. Sheet body for the filter, and see, right click. All right, need to get into the part. Okay, so what you will need to do is first double click either one of this part. That will get into the actually modify the individual part. Okay, so basically we are in modeling again within this assembly environment. So even if you can go to the part navigator, you can actually make changes to the parts. Anyway, so we use the sheet body filter, and you can select everything and press Ctrl B, which is a shortcut for hide. Okay, I think we don't need to go into the individual part. Anyway, so that's how you add a individual part when you first build the assembly file. So what if I want to insert another part? We can use this command. And if you don't have this toolbar, you can click Start and look at here. That's assemblies. If you don't have the check mark here, it's not there. So you want to check this, then you have this toolbar. And you can click. Again, that's the same dialog box we just saw. So you can pretty much select everything here. It will not show you the duplicated part. So we have on top, bottom, and the spring. We can add the handle, the latch by press Control and click. Okay, I think that's the two left. So apply. All right. And again, we can just use this filter and press Control B. Yeah. So we don't need to go into the individual part. Okay, and we need another handle. So let's first move the assembly first. Okay, so now we have some parts on the screen, and since when we built the individual parts, we set for example, we set the origin for the top blade to this hole, and we set the origin for the handle also at the same position. So pretty much they are aligned already. Then we still need to move them around a little bit. So first I'm gonna fix this top blade because think this working environment is like a universe, a free space. So your model should not be floating around, and you need one piece that's fixed. So we can add a constraint, okay, and select fix, and make sure there's no selection filter. So we're gonna fix this top blade. Click OK. Now this is your anchor point for the whole assembly. The next step, we're gonna add other constraints. Now first we're gonna use fit constraint, which is, I believe, here. Fit. So fit is for two cylindrical faces. It's not for the edge of a cylinder. It's basically for the two face, and they should have the same diameter. So if you want to put a pair of holes with different diameters, it's not gonna work. Okay, so we use fit for the same diameter holes. and you can see the icon. So what will happen after you add fit constraint? We can try to move this part. Okay, go back to no selection filter, and we can select this. There's a quick menu. This is a move. Okay. Now, once you click move, you have some options. This is dynamic, and it's like move object in the model. Okay, so you can move this along 3 axis and the rotation. Now, since we put the fit constraint to this 2 holes, you can see I will be able to rotate, okay, on the axis, but I cannot move on the Y because we had this constraint. And you can move along the axis also. So with fit constraint, you can only put 2 holes on the same axis, but they're not touching each other. But you cannot constrain the position along the axis. Okay, so that's how you first move a component, and second, how the fit constraint works. All right, now how to put this tool at the right position? We need another constraint. Okay, so the next constraint we're going to introduce is touch align. So in the slides, it's the first one. So that'll be a better example. Like this piece is sliding on top of this rail. That'll be a touch constraint. So basically here the 2 face, this face and the bottom face of that top blade, they should be touching each other. So we can use touch align, and we can choose prefer touch. Okay, so we're gonna pick the face, the pair of faces, and now you can see the bottom blade just jumped up. And now let's try to move this bottom blade. Okay, you can hold. Basically now the only thing you can do is rotation. There's no translation at all. Okay, so that'll be enough to constrain the bottom blade. Okay, so what's next? We're gonna I think we can move this spring. We don't need this right now, and we can also move this latch. Okay, now we're going to put constraints for this handle and this piece. So let's see. Actually, this hole should be aligned with the top blade, the hole on this position. So first, let's use fit again. Okay, so fit either one, the top or the bottom cylindrical face. Okay, then the next will be the face on the top blade. Okay, now as you can see, it's not centered. We can use another constraint to center this handle to the top blade. That will be center. So let's see where's the center. We have some options in the center constraint, and that's here 2 to 1, 1 to 2, and 2 to 2. So basically, let's take 2 to 2 for example. So let's see, we have 2 parallel faces on the handle, top and bottom. And we have another two pairs of faces on the top blade, this, the top and the bottom around this hole. So we can put that pair of face in the center of this pair of face. Okay, so first let's select two pairs, two faces, one pair. Okay, top and bottom and top. So this will be the first two. Then the second two will be here. Okay, so that means this the center of this pair is aligned with the center of this pair. Okay, here. So if you have something like you have a point in the middle of this cylinder, so you can use 1 to 2, which is 1 is the point, 2 is the pair of the face. Okay, so that's the way to do it. And all we need is the second handle. We can add another handle here. Apply. Okay. Maybe we can try something else. So handle. We used absolute orange, and we can use by constraint on the fly. So you can click OK, and it will ask you to pick a constraint. And let's see. We can use fit for, well, which one? Fit for this face and to this face. And try to click OK. Of course, the orientation is off. And let's first hide those sheets. Okay, Control B again. Then try to rotate this 180 degrees. If I can rotate that, no. Cancel that. Yeah. Well, just to demonstrate, when you add a part, you can use other options to position the part. Okay, and it's hard for me to rotate this thing, so we can deactivate this constraint, then move this handle 180 degrees, and as you can see, the angles, they snap to a 5 angle per move. Okay, apply, then we can put this constraint. Well, that doesn't work. Okay, 180 first. Then we can add another fit constraint for this face to that face. Okay, and now we can keep moving this part. Now we can add another center constraint. So center, that will be 2 to 2. Okay, now we can even select this pair of face first. Then center to this pair. Okay, now we're gonna let's put these two holes together, and that will be another fit. Fit, and we will select this face to that face. Okay, so now things are a little bit weird. We can try to move the bottom blade and rotate. Okay, and we will rotate this. Okay, that's much better. All right, then see what we can do. Okay, for the latch, we will use two constraints. So first is concentric. Concentric is a little bit different from fit. Beside the concentric, you can use that for two different diameter edges, and the fit is for the same diameter. Then the concentric is essentially for a 2D shape, for the edge of a cylinder or a circle on a face, and the fit is for your cylindrical faces. So just keep them in mind. So if you use concentric for this edge and the top edge, this latch will be buried under into the handle. And for concentric, this two circle will be on the same plane. So let's try for the bottom edge and the top edge. Okay, as you can see, the latch or these two edges, this edge and that smaller edge, they're now coplane, and that's why you have this this top here is a little bit overlapping, but as I said before, it's idealized, so you don't have to worry about that. And if you want practice other constraints, we can use maybe angle to define the angle of this latch. Okay, and that's also pretty easy. Let's find the angle. So 3D angle, okay, that's fine. We can define the angle between this to maybe this piece. It's not a straight face. Okay, let's try to use different angles. Somewhere here, 15. Okay. All right. So now if we move this handle, okay, the angle between these two they'll be fixed. So that's it. And then for the spring, since we don't have there's no cylindrical face, there's no circle on this thing. So I think we just move this spring to a better location and wait. Where's the spring? This spiral, okay. So maybe a little bit higher. Okay. Now that'll be enough for the spring. And yeah, there's overlapping here, but we just put it there. Okay. And for the simulation, we will not use the spring at all. So that'll be the assembly. And some of you might prefer to use different colors. So you can right click on the part, and that's edit display. You can change the colors to whatever you like. Okay. So that's the assembly, and the next step, we will need you to make some mechanical drawings. So after you finish this assembly, we can go to Start, and here's your drafting application. Once you click Drafting, okay, you will have the dialog box. I think by default it's on the template, and we want to use standard size. The template is basically you have this title and the border, and we don't really need those, so we will use standard size, which is pretty big, easy. Then click OK. Okay, so I think you might have some options like this one, but it depends. I think I made some change to my NX, so it will be different. Anyway, if you have that, the base view here, if you have the option to select Start View, great. You can choose the wizard, which is step by step, and you can look into that. That's pretty easy to understand. Or you can use the base view command, which is the same as what I'm going to do in this one, base view. So after you click OK here, you will see this window. And okay, now you have the options to choose which way you want to orient your part on your assembly, and you can choose different scale. Okay, so maybe 2:1. You can put this thing like this, and next you can pull to the left or right, then top bottom, so you can have the left view. Just drop here. So you can keep doing this, and I think that'll be enough for this part. Okay. Now we have two views. That's the top. I think this is the right view. Okay. Now let's see what's next. So okay. Maybe dimensions. First, let's see. Dimensions is after that. Okay. Now let's use the cross section first. What if we needed to make a cross section of the handle, because the handle has complicated cross section shapes, and maybe here you want to have a look at how the cross section of the blade will be. So we can add a cross section using this command, section views. Okay. So in this command, first you're gonna pick the view. So you have your top, and you have the orthogonal view. Let's see where's. Okay, that's a part navigator, and we can see we have one. This is your main view. Then you have a projected from this view. That's gonna be the orthogonal 2. So we're going to cut the top view, and let's select the view first. Okay, and then you have the we will care about some here, the hinge lines. We have the inferred hinge line. Then we have the this is define your own hinge line. So inferred is basically you can snap to horizontal or vertical positions. Okay, then this define hinge line you can let's see, you can use some tilted position. You can use inferred, or you can use 2 points. Okay, let's try 2 points first, from this point to that point. So we can have a cut that's parallel to this the ISO line of this handle. So we can cut here, and you can drop your view probably here. Okay, so now let's see. It's making a cut at this position, and it's also cutting into this. Okay, so that's how you make a cross section, and you can also have the option for this cross section. So 2 ways: you can right click on the part navigator, or you can right click on this box. Okay, and this AA is your style option. And here you have a lot of options. First, we can, I think it's on the section tab. So in the section tab, you can uncheck this background option. So once you uncheck this, look at here, and once you click OK, you will have a very clear view, only showing what you cut, okay, not something behind the this cut. So this is very useful for, let's say, maybe something like this. When you cut, you don't want the background to interfere with your viewing. So that's how you turn off the background of this cross section, okay, which is also detailed in the slides. Then we can also add dimensions for this assembly, and you can use this invert dimension, okay, and I think most of the dimensions will be using this command. We can also, before you drop some dimensions, we can change the reference of your the format of your annotation. So we'll go to reference preference annotation. Okay. So here it's everything that will define the format of your annotation. So you have the character size. That's basically the size, the height of your texts, the text, the height of this, and you have the units. Okay, some of you are very annoying about. I'm sorry, some of you are annoyed about this comma here. So you can use this. You can change that back to the this format. And sometimes for the we have the fraction dimensions. You can use fraction dimensions for some pieces. Okay, and here in dimension you can have your position. 3 decimal points. This you can have 4 decimal points, 3, and that's your tolerance. Okay, so you have a lot of options. What I'm going to do, I'm going to just change this to the point, change the comma to the point, and I think the letter might be too small, so 0.4, let's say. Have a look. Then invert dimension, what we need for the dimension, let's see, maybe the center of this hole to the center of this hole. So that will be a, this is an assembly dimension. So, okay. And if you put this, if you close this blade, you can get the overall length of this cutter. And I'm not going to, well, let's go back and modify that. So you can go back to modeling. Now that's our model. And let's try to close the mouse here. I think that's aligned. Okay, now this is aligned. Click OK. That will be the aligner position. And yeah, don't worry about the spring. So anyway, um, maybe turn this on a little bit. Maybe 10 degrees. Okay. Okay, and let's go back to the drafting. You can come to the start and go to drafting. So as you can see, once you modify the assembly, the drafting will change. That's what we said in the first class, I think. There's the different applications, modeling and drafting, and the assembly and the parts. Once you change or once you modify one thing, in other applications you will be change as well. So, and after you change, you want to update this sheet. So you can right click on the sheet and then choose update. Okay, so as you can see, the cross section also changed. It will automatically update. Okay. Now we can drop some dimensions here, like the overall length and the overall height of this model. Okay, so for the report, you will need to submit a sheet with at least two views. Okay, top and maybe left or right, and you also need to submit one within this drafting. You also need to include one cross-section view, and also you need to give us some dimensions, overall dimensions. You don't need to give us a lot of dimensions, and maybe you can put some like diameter of the hole. Okay, so that will be detailed in the midterm report standard. And this will be all for lab 6. And after this, probably we will have a F and Q section. You can submit all the issues, all the problems you have during this project. And for some common problems, I will make some videos show you how to solve this problem. Okay, and thank you very much.